In this video, we'll be looking at section 9.4, dilations. And our essential question will be, what is a dilation? So a dilation is a shrinking or enlarging of a shape typically done on an XY plane. The XY plane just being where we have our X and Y coordinate axis, where we plot points and draw lines and parabolas and all that. So we'll need some definitions first. Our first definition will be preimage. And the preimage is simply the original shape. Next, we'll have the image. And the image is the new shape. So we have a preimage, our original shape, and then we'll either shrink it down or enlarge it, and that'll become our new shape. Then we have the word enlargement. And that's where the preimage is larger. I apologize. The image is larger. Is larger than the preimage. So your new shape is larger than your original shape. The image is larger than the preimage. And then we have what's known as a reduction. And that's where the image is smaller than the preimage. So we have a preimage, it's our original shape. We have our image, that's going to be the new shape. And then we have an enlargement, and that's where the image is larger than the pre-image. And we have reduction, where the image is smaller than the pre-image. So the definitions we're going to be working with. And then here's how we can perform or talk about scale factors of a dilation. So I'm going to draw two images. So this triangle is 3 across and then 4 up, and this triangle will be 1, 2, 3, 4, 5, 6 across, and then 2, 3, 8 up. And we'll call this triangle A, and we'll call this triangle B. So we're going to determine if the transformation from A to B is a dilation, and then tell whether or not it is a enlargement or reduction. So the way we determine if it's a dilation or not is we have to check to see that we have if our side lengths are proportional. So I'm going to assign some side lengths, some corners to this. So let's call this H, G, I, and then we'll call this one J, K, L. So what we can say is anytime it looks like we're having a dilation, we know that we're always going to have this angle that they share. So we already have our congruent angle where angle G is congruent to angle K. So there's our angle. Now we just need to see if our sides, our corresponding sides, are proportionate, and if they're equal ratios, then we can say the triangles are similar, and that's how we know it's a dilation. So this side length is 1, 2, 3. And then JK is 1, 2, 3, 4, 5, 6. And then G to I would be 1, 2, 3, 4. And then K to L is 1, 2, 3, 4, 5, 6, 7, 8. So let's check on our proportions. I'm going to say HG is to JK. As IG is to LK. So let's check to see if our sides are proportionate. So I'm going to plug in my values, and I get 3 over 6 equals 4 over 8, which simplifies to 1/2 equals 1/2. So we got our proportionate sides, we got our angles, so we can say triangle HIG is similar to triangle JLK. So the transformation is a dilation. Now to find the scale factor is a dilation that is an enlargement. We have to tell if it's an enlargement or reduction. And it's an enlargement because my first image, I'm going from A to B. I'm transforming from A to B. So my first image is enlarging to my second image. Now to find the scale factor, this will be the last piece we talk about. All we're going to do is we're going to take our image a side length from the image, and then we'll divide that by a side length from the pre-image. And they have to be the corresponding ones. Like, for example, I could do JK over HG. So, from our above example, we'll say JK over HG is equal to 6 over 3. So that tells me my scale factor is 2. So that's how we can verify if two images are dilations of one another. We'll find out their sides are proportionate, and then we can look at a scale factor. One quick note I want to make is that scale factors can be fractions. So just keep that in mind. That's how we're going to look at similar triangles through dilations. So thank you for watching this video, and I hope you have a great rest of your day.